Today we're going to start our unit on area and perimeter of two-dimensional objects. And we're going to start with kind of reviewing some of the basics, the area of a rectangular and a parallelogram. Now, some of you may recall that the area of a rectangle has traditionally been called length times width. In our uses, in order to apply this to a variety of figures, instead of calling it length times width, we're going to simply say base times height. Now, one thing to keep in mind is that when we're referring to the base and the height of any object, we call that the base and the height must be perpendicular. So when you're looking for that base and that height in any object, make sure you're finding those perpendicular parts. We're also going to be looking at what a composite figure is and how to use some of these area formulas to find the area of a composite figure. So as our example here, we're looking at a real-life situation where Lisa works in a billing department for A Cut Above, which is a company that builds custom countertops and tabletops. A new customer has contracted A Cut Above to build the tabletops for a theme restaurant called Shape Up. Each tabletop costs $8.50 per square foot. We'll come back to that later. And Lisa's job is to calculate the area, compute the charge, and then bill each customer properly. The tabletops made with laminate wood are delivered to A Cut Above in different rectangular sizes. Before there are any cuts, a cardboard template is made to use as a guide. Lisa uses the templates to investigate the areas. Shown is one of the templates for which Lisa must find the area. So if we're looking at some different methods for finding the area of this shape, we can look at dividing this up into a combination of rectangles. You can divide this up a couple of different ways. Some people might go draw a segment straight down here and divide this into this vertical rectangle here, and then this smaller rectangle next to it. You could divide it up a couple of different ways, but I'll just go with that one. To find the area of this shape, we're going to need to find the area of both of these individual rectangles. Now remember that area is base times height, and since these are rectangles, we do know that there are right angles, so we know we have that perpendicular height. The base of this red one is 2 feet, so we can plug that in for the base. The height, we're going to have to do a little work to find the height combination. We can see that it is 3 feet from here to here, but by using this 2 right over here, we can see that there's an additional 2 feet right here, which means that the full height of this rectangle is 5 feet. If we plug that into our formula, 2 feet times 5 feet, we get an area of 10 feet squared for that rectangle. Now pause for a moment here. Why are the units squared? Remember that in multiplication, if we are multiplying 2 feet times 5 feet, we can multiply the values themselves, so 2 times 5, because remember we can multiply in any order, but then we're also going to be multiplying the feet times the feet. Well, 2 times 5 is, of course, 10, and feet times feet is feet squared. So whenever we are dealing with area, we're always going to have those squared units. Now, if we move on to the blue rectangle, again, we're going to use that same formula of base times height. Keep in mind, it doesn't matter which one is the base and the height, since we are multiplying them, and multiplication doesn't matter the order. So I'm going to look at, there's my right angle. I'm going to look at the height being this 2 feet, and I'll plug that in first. Now, for the base, the 6 feet down here is referring to this full segment. Keep in mind that we are only wanting this part from here to here. So if you look at the 2 feet from up above, we know that this little piece represents 2 feet. So if we do 6 minus 2, this piece here must be 4 feet, which is what we're going to be using for the base. So now we've got the area of this rectangle to be 8 feet squared. And if we want the total area, we're going to need to add both of those areas together. So the total area is going to be 10 feet squared plus 8 feet squared, which gives us 18 feet squared. Now, in terms of how much should Lisa charge, it tells us above that it's $8.50 per square foot. So we need to take that 18 feet squared, multiply that by 850, and Okay, so if we multiply the 18 square feet by the 850, we're going to get a total of, going to get a total of $153. So there's an example of kind of a combined figure, a couple of different rectangles. We might have to do some, finding some missing pieces of information. Now here's an example of a parallelogram tabletop. Recall that for a parallelogram, we are going to use the same formula, area equals base times height, but remember the base and height must be the two perpendicular pieces. So when we're looking at the figure for the base and the height, if I call the 3 feet the base, then this 1.5 feet is going to be the height, since we can see that they are perpendicular. So the area will be 3 times 1.5, which is 4.5 feet squared. Once again, it does ask us to determine the charge for making this tabletop. So since it's $8.50 per square foot, if we want to know the charge, we can multiply that 4.5 square feet by $8.50, and that gives us $38.25. Now do keep in mind that sometimes we're going to be talking about area versus perimeter. Area involves the space inside the tabletop. So when we're talking area, we are talking about this full space. If we are talking about perimeter of the tabletop, the perimeter is the distance around the edge of the tabletop. So in this case, the perimeter would be adding together all 4 sides. Since it's a parallelogram, we do know that the opposite sides are congruent. So if I wanted to find the perimeter, it would be 3 plus 3 plus 2 plus 2, which is going to be 10 feet. Now also remember that with perimeter, since we are adding units, not multiplying, we are going to keep the common unit, not multiply them together. We will not have squared feet for perimeter. Okay, the following example is what we call a composite figure. Now, a composite figure is simply made up of 2 or more simpler shapes, such as triangles, rectangles, parallelograms, all of which we're going to learn about in this unit. Composite means that they're made up of distinct parts. So, looking at this figure as another tabletop, we can divide this up a couple of different ways. Some people might see some triangles. We can definitely see a rectangle. I'm going to go with the rectangle that we see here. And rather than separating that into 2 triangles, since we have a formula for a parallelogram, I'm going to use this as find the area of that parallelogram. When we're trying to find the composite, the area of a composite figure, we're going to need to find each individual piece and then add those together. But keep in mind that sometimes you are missing information and you need to do some work to find that missing information. Okay, so let's start with the area of the red rectangle. This one we can clearly see a base and a height with that right angle. So the area of this is going to be 5 times 6 or 30 feet squared. It's the parallelogram, though, that's a little bit more complicated because remember that in our parallelogram, we do need to look for right angles. Okay, a parallelogram itself doesn't necessarily have right angles. When we're looking for the area of, when we're looking for the area then of this parallelogram, keep in mind, always look for that right angle, which we can see right here. The 2 segments that are forming that right angle then are this piece along the bottom and this piece right here. Now we know that piece along the bottom. Let's go ahead and call that the base. But we are missing this piece, and we do need that to represent the height of that parallelogram. So now we can look back at the fact that this is a right triangle in here. We do know that based on this 5 right over here, we do know that this is 5 feet right here. Since it's across from the right angle, we're going to call that the hypotenuse of the triangle. So if I use my Pythagorean theorem, and if it helps, you can always redraw it. We have a right angle here at D. This is 3 down at the bottom. We have 5. And we're solving for this segment BD, which is one of the legs. So 3 squared plus my missing side squared equals 5 squared. Some of you might recognize that this is one of our special Pythagorean triples. If you don't, then you can do the math. This is 9 plus b squared is 25. B squared is 16, which means B is 4. So once we've calculated our missing height, I'll label it in my picture, Now we can come back over here and finish finding the area of the parallelogram. It is 12. We're multiplying feet, so that's going to be feet squared. Our area of the full composite figure then is going to be the rectangle at 30 feet squared plus the parallelogram at 12 feet squared for a total of 42 square feet. Okay, and again, if we needed to calculate the cost of the tabletop, we're just going to take that $8.50 per square foot, multiply that by 42 square feet. 42 times 850 is $357 for this tabletop. So we've seen a couple of examples, and one of the keys that I do want to mention before we look at the last set of problems is that we do need to, in many cases, find additional dimensions that are not specifically given. And as we look at some of these next few examples, we need to pay attention to all of the different properties and theorems that we've learned in the past that are going to help us find those missing dimensions. So here's a few more examples of applying what we've learned. To find the area of the composite figure in number 7, we can split the figure up into two rectangles. Again, you can either go draw a vertical line up and down, or if you prefer, you can draw your vertical line. You can draw your your horizontal line, like this. So either way, divide that up into two different rectangles. Look for some of your missing dimensions. For example, if I go with this one, I can see that this smaller square on the top has a base of 4.5 and a height of 4.5. Keep in mind a square is a type of rectangle, so we can use the same formula, base times height, which means we're multiplying 4.5 times 4.5 for the area of that square. Now for the area of this rectangle at the bottom, we can see that the base appears to be 9, but we are missing this height. So again, look at the other dimensions that you're given. We have this full height of 7.5 millimeters, and then across here we have 4.5 millimeters. If I want to find the missing height, I need to do 7.5 minus 4.5, which means my missing height here is 3. Now I can go back and find the area of that rectangle, base times height. I'm multiplying 9 times 3, and I'm getting my area here. Your final composite area, remember, is the combination of the two areas added together. So I'm going to ask you to find your composite area, and we can enter in that answer to see if we are all correct. Okay. If you have gotten an area of 47.25 millimeters squared, you are correct on finding the area. Now we want to determine the area and perimeter of a rectangle with a length of 12 centimeters and a diagonal length of 13 centimeters. Again, when you don't have a picture in front of you, draw the picture. So I'm going to start with just drawing a rectangle. I know that the length is 12 centimeters, and I know that the diagonal is 13 centimeters. Now to find the area, I need to multiply my base times my height. I can see that my base can be this 12 centimeters, but I am again missing my height. So I can plug in my 12 for the base, and I'm going to have to come back and find the height. Remember that a rectangle has a right angle, which means I once again have this right triangle. And to find the height of the right triangle, I can once again use the Pythagorean theorem. Some of you, again, may recognize this as one of our Pythagorean triples. If you don't, we can just plug it into the Pythagorean theorem. 12 squared plus our missing leg squared equals 13 squared. That's 144 plus b squared equals 169. B squared will be 25, which means b is 5. So the missing height that we are looking for here is 5, which means that the area of this rectangle is 60, and our units are centimeters, so centimeters squared. The second part was, of course, finding the perimeter of the rectangle. Remember that the perimeter is to add up all of the sides. So for the perimeter, we're going to be adding the base of 12 plus the 12 on the top. We're also going to be adding the height of 5 plus the 5 on the other side. We do not need to use that diagonal of 13 for part of our perimeter. So our perimeter is 24 plus 10 is 34 centimeters. And again, we do not have squared units on perimeter. Okay. Number 9, determine the area and perimeter of the parallelograms shown. We're going to have to round our answers to the nearest tenth. So right away, that's telling me we might be getting some decimals on here, okay? And again, we are going to have to find some of our missing lengths. So what I'm going to do is start by having you find the missing heights of each of these. And then we're going to come back and find your actual area and perimeter. Notice that in each of these cases, we're looking for a base, such as this one, the 5.5, and we're looking for a height, which is unknown. Now you'll notice, however, that we do have, over off to the side here, a little right triangle with a 60-degree angle. That means that we are dealing with this 30, 60, 90 right triangle, and we can use our shortcuts for a 30, 60, 90 right triangle. If this is 60, this is 30, I've given you the hypotenuse of 4. Remember that you want to find your short side first. So my short side is going to kind of be my A value. My hypotenuse is 4. Remember that if we know my hypotenuse, all we need to do is divide by 2 to get that A value of 2. Now, to find the height, remember that the height was A times root 3. So once I know that my A value is 2, my height is 2 root 3. In terms of finding the area then, if I know that this height is 2 root 3, to find the area, I can multiply my 5.5 times my height of 2 root 3. Since it does say that we can use a decimal and round to the 10th, I'm going to go ahead and put that in as a decimal. Let's see, we've got 5.5 times 2 times the square root of 3. And unfortunately, I do not have a good calculator. Hold on one second. Okay, so it looks like our area is going to be 19 point. It says rounded to the 10th. I have 19.05 with rounded to the 10th. That would be 19.1. My units are feet squared, so my area is 19.1 feet squared. For my perimeter, again, make sure that you are using the edges. So the perimeter, I'm going to do my 5.5. Do this underneath maybe. Perimeter, I'm going to be adding my 5.5 at the top and at the bottom. So if I want to, I can just double that. Plus, I have 4 feet along the side and another 4 feet along the side. So once again, if I just want to double that, that's going to give me 11 plus 8, or 19 feet for my perimeter. Now keep in mind, we are using a lot of our prior skills. So as we look at this last example, once again, we've got a parallelogram. We know that for the area, we're going to need the base and the height. That means I'm looking for the two sides that are perpendicular. I know the base is 14. But once again, I am missing the height, okay? We can see off to the side here that I have this little 45-45 triangle. The 7 yards, I'm sorry, it's yards, not feet. My 7 yards on this side can also be used right over here. So if I look at this little 45-45 triangle, remember that if I know the hypotenuse, all I need to do is divide by square root 2 to get one of my missing sides. And keep in mind that in a 45-45 triangle, both sides are the same. So once I do 7 divided by the square root of 2, that's going to give me this missing side. Now I'm just going to write it as 7 over square root 2 for the time being, because I don't want to do any rounding until I get to the very end of the problem. So now I know that my height is 7 over square root 2. And now I can multiply these together in my calculator to get an area of about 69.29. Now once again, if I'm rounding to the 10th, that's going to become 69.3. My units were yards. It's area, so that's yards squared. There's my final area for this one. And then finally, the perimeter. The perimeter, we're just going to be adding up all the sides. We have 14 along the top and 14 along the bottom, so 14 times 2. We have 7 along one side and 7 along the other side, so that's 7 times 2. That's 28 plus 14, giving us a perimeter of 32. And once again, our units are yards. So your task tonight is to practice some area and perimeter problems dealing with parallelograms, rectangles, and some composite figures. There's a worksheet that you will find on Schoology that can be completed. There's also going to be a Delta Math assignment. Please remember to always be checking the calendar for anything that we're supposed to be working on. The Delta Math assignment is going to be a combination of all of the different area problems that we're going to be working on over the course of the week. You won't be able to do every problem on there right now, but what you might want to do is go on to the Delta Math and start a little bit of it, find a few of the problems that you are able to successfully do, problems dealing with rectangles and parallelograms specifically. And then each day as the week goes on, you're going to be practicing, just adding in a few more of those problems for some of that practice.